Okay, so in today's presentation, we're going to be talking about electronic cigarettes. Now, I picked this topic because I thought it would be relevant to today's society and more importantly to the age group that I think is going to be watching this. So let's move forward. In the next slide, we have information regarding electronic cigarettes. Now, we're going to be using the terms vapes and electronic cigarettes interchangeably as they're kind of the same thing. So before we get into any information in specific, if you just look to the left, this is to familiarize you guys with vapes, just in case you weren't familiar with it already. So you're going to have, I think, one of the most common ones. You're going to see a puff bar right here. Now, puff bars are going to be known as disposable vapes. There are many more, but those are just one of the most popular. Then you have in the bottom left here, you're going to see tanks and mods. These are kind of more hobbyized, if you will, if that's the proper term. Then you have the two other more popular ones with rechargeable e-cigarettes and disposable e-cigarettes. These are going to be more popular. If we're going to go over some information right now, you guys should know that vapes work by heating a liquid. This liquid, when heated, is going to produce an aerosol that you inhale into your lungs. Okay, now this liquid can contain nicotine, THC, CBD, and other substances, flavorings, and additives. But today we're going to be focusing on nicotine, okay? Just something to note here that vapes are still fairly new and scientists are still learning about their long-term health effects. So in the next slide, we're going to be going over how nicotine chemically affects your brain. So here on this slide, we're going to be going a little bit more specific about how nicotine, once released and inhaled into your body, is going to go from your brain stem up into your brain and what parts of the brain and what does what. So if you guys look to the right here, the only picture on the screen, this is going to be like the dopamine reward pathway. What this is going to explain is how nicotine eventually gets to the receptors and causes a dopamine release. So what the text to the left is going to explain the picture on the right. So nicotine binds to receptors in the brain, augmenting the release of numerous neurotransmitters, including dopamine, serotonin, norepinephrine, acetylcholine, gamma-aminobutyric acid, and glutamate. Now, the smoke also has other psychoactive properties apart from nicotinic receptor stimulation. For example, it inhibits monoamine oxidase. Now, this is kind of just fancy terms for the enzyme responsible for breaking down the biogenic amine neurotransmitters, norepinephrine, serotonin, and dopamine. And remember, all this is occurring in the brain thus far. So what the picture on the right is going to talk about is starting at the brain cell. It's going to be, or a little bit past the brain stem, forgive me. It's going to be that the nicotine enters the brain. Then at the VTA, VTA is just an acronym for ventral tegmental area, is the stimulation of the nicotine receptors. Now at the nucleus accumbens, this is going to be near the area where dopamine gets released. And once dopamine is released, it goes to the prefrontal cortex. Okay, so on to the next slide. So in this next slide here, we're going to have the chemical makeup and also another explanation, if you didn't get the first time, of how of what nicotine does to the body. So if you look to the left here, we're going to have the chemical makeup of nicotine itself, which is going to be C10, H14, and 2. Nicotine itself is a naturally occurring toxic formula that's found in tobacco plants. In its natural state, it has a fishy odor when warm. Also, something else, nicotine is a simple sympathogenic drug that releases catecholamines. It increases the heart rate and cardiac contractility and constricts cutaneous and coronary blood vessels transiently. increases blood pressure. Now, with all that being said, I think we are done here.